This video is going to be about summarizing distributions. We're going to dig deeper into our data distributions. Today's learning target is I can determine the mode of a data set. I can determine an appropriate measure of center for a data set. And I can determine an appropriate measure of variability for a data set. Let's do a warm-up. What type of distribution is this? Is it A, uniform distribution, B, a normal distribution, C, is it skewed left, or D, is it skewed right? So go ahead and answer this question. Alright, if you picked B, normal distribution, you are absolutely correct. B is the correct answer. You can see that the distribution is like a bell curve with equal amounts of data on both sides of the measures of center. In the middle, 50%. Today we're going to talk about measures of variability. When we talk about measures of variability, we want to talk about how the best way to interpret our data for how well our survey was, how well our data represents what we were trying to figure out. That way we can make predictions in the future with our data. That's why you use data. Variability means that if you give the same amount of people the same kinds of questions, or you have the same scenario, your results should be close to what you have collected data on from before. So the range and the interquartile range are measures of variability because they show the spread of the data. That means the two things show how far away from the mean, which is the average, the data values are. The larger the range and the interquartile range, the more unpredictable the results of your future instances of the survey are going to be. It wouldn't be a very good measure of standard procedures. A normal and uniform distribution, that's where we have the bell curve or it's a flat. Both the range and the interquartile range are good measures of variability. In a skewed distribution, though, when all your data is over to one side or the other, the best measure of variability is the interquartile range, because that is not affected by any of the outliers. Remember, when we have skewed distribution, we have outliers in our data. This table puts everything in order and organizes it. It would be something that you might want to keep or copy, because this will show you exactly, explain it, the best measures of center and the best measures of variability. Now remember, if the data set has an outlier or everything's clumped on one side, the range would misrepresent the data spread. The outliers increase the spread. It makes the data look more spread out than it really is. You would be better off looking at the interquartile range, which is a much better measure of skewed data, because it describes the middle 50% of the data. Remember, the box in the box and whisker plot, it shows the middle 50% of the data. So the interquartile range would be a better measure of variability. I want you to look at this box and whisker plot. The top one, medium to large dogs. What do you think the best measure of variability is for number one? Then I want you to look at number 2, where it says temperatures. Look at the box and whisker plot. Which one of the measures of variability would be better for number 2, the temperature range? Would it be the interquartile range or the range? Just the range of the data. Okay, if we look at our interquartile range of our data for number 1, the medium to large dog weights, we have an outlier over here. So the best measure of variability for the top box and whisker plot would only be the interquartile range. Because of the outlier, it skews our data. Our data will be skewed. So the better measure is this range here, the interquartile range, between 51 and 55. Because this shows the middle 50% of the data. For the second one, the temperatures, the best measure of variability could be either one, because there is no outlier here. You could either use the interquartile range, which is the data that's in here, or the range of the data, because most of the data is in that it's not spread out like it is up here in number 1. Okay, look at this one. Look at this box and whisker plot. Which statement is true about this distribution? A, either the interquartile range or the range are good measures of variability because the distribution has no outliers. B, the range is the best measure of variability because the distribution has an outlier. C, either the interquartile range or the range are good measures of variability because the distribution has an outlier. Or the interquartile range is the best measure of variability because the distribution has no outliers. Go ahead and answer that question. I hope you picked A, because the data here, you see that there's a range between 10 and 45. That's a 35. The range would be 35. And the interquartile range is the same. The IQR, 40 minus 15, that would be 5, 25. This is 25 here. So those are pretty close together. Because there are no outliers, you can use either the IQR or the range of the data for your variability. Let's look at this question. Which statement is true about the distribution? Okay, look at this box and whisker plot. Oh, what do we have over here? Think about what's happening there. And let's pick the statement which is true. Is it A, either the interquartile range or the range are good measures of variability because the distribution has no outliers? B, either the interquartile range or the range are good measures of variability because the distribution does have an outlier? There's C, the IQR is the best measure of variability because the distribution has an outlier. Or is it D, the range is the best measure of variability because the distribution has an outlier? Go ahead and answer that question. So I hoped you picked C. This definitely is an outlier. That's an outlier. So that's going to skew our data. And the best measure of variability is going to be this measure here, the 48 minus 15. Remember, that's how you find the IQR. 48 minus 15. So that would be 33. What would happen if we didn't have any outliers? If we took that outlier away, we would have more of a bell curve, a normal curve. Right now, it's like this. So it's skewed to the right. So I hope you got that one correct. All right, let's look at this line, at this dot plot. How many observations were made in gathering this data set? Remember, each one of those X's represents one number. So, is it 3? Is it 8, 10, or 14? How many observations were made in gathering the data? So how many people answered their question? Well, if you picked D, you got it right. All you have to do is count these X's. So you pick 14, 14. That's how many X's there are. You just have to count the dots to figure out how many responses were gathered. All right, let's look at these four different distributions. For which distribution is the median the best measure of center? The median. Only the median. If you picked A, that's the correct answer. Let's look. The median is right here. This is a skewed, everything is skewed over. All the data is clumped over here. And remember what we said on our table here, that when there is a skewed set of data, that's the best measure of center. Skewed either left or right. Our last question is, describe the data distribution on this dot plot. Is it a normal or bell curve? Is it skewed to the left, skewed to the right, or is it a uniform distribution? I'll give you a hint. I'll even draw like a best line of fit. What does that look like? If you picked A, you are correct. Good job, guys. All right, go ahead and take a break, and we'll talk to you another day.